Thank you for coming. So this is our first session of TF Club. In TF Club, our goal is to learn how to build end-to-end production-ready machine learning models using TensorFlow and Keras. So this is our first session, and TF Club will take place every Fridays at noon. And since we are going to record every session, if you miss any session, you can get them on Confluence on my blog. And yeah, I want to mention here that the other thing is every week I will post programming exercises on the Slack channel with their solutions. So if you have time, they are optional, but if you have time, it is good if you get your hands dirty to learn TensorFlow in a better detail. It is good if you try the programming exercises. And the other point that I want to mention here is the slide. Most of the slides that I am going to use are from Google Advanced Solutions Machine Learning Immersive Training that my colleagues and I participated for the last month. So let's get started. So today I'm going to talk about TensorFlow fundamentals, and also to make sure that everyone is on the same page, I will give an overview of machine learning types and which types of machine learning we are going to mainly try to build with TensorFlow. Things that many people ask is what is the difference between AI, machine learning, and deep learning. And as you can see here, machine learning is part of AI. So we have symbolic AI, where we explicitly express knowledge, and we have machine learning, where the machine learns from the data, and deep learning is part of machine learning. So we have different types of machine learning, whereas deep learning is one type of machine learning that uses mainly neural networks. These neural networks are loosely inspired by the way that our brain works. By the way, this figure is from Deep Learning with Python book. This is a really great book, and it was recommended to us by our Google's machine learning engineer teacher. So if you are interested to explore deep learning in a better detail, I recommend this book. So the other question is, what's the difference between machine learning and classical programming? So in classical programming, the inputs are the rules and the data, and we get the answers. Whereas in machine learning, the inputs initially in the training stage, the inputs are the data and the answers, and then the machine, it learns from a possible set of hypotheses. It comes with the best rule that can map from the data to the answers. Then once we get the rule in the machine learning stage, in the training stage, when we have data that doesn't have answers, using the rules that it learned, using the mappings that it learned, it gives us the answers. And the kind of machine learning model that we have to use depends on the kind of problem we are solving and the data we have. And there are different types of machine learning, but mainly we will focus about supervised learning in TF Club. So supervised learning is if the data is labeled, and if it is not labeled, we call it unsupervised learning. Examples of unsupervised learning include clustering, dimensionality reduction, and other techniques. And in supervised learning, we have two types: regression and classification. If it is continuous data, if the response or our level is continuous data, it is regression, whereas if it is categorical data, it is classification. And it is in this supervised learning that machine learning has shown lots of development and and it is also an area of very active research. Deep learning also, most of the innovations, cutting edge applications of deep learning are also in supervised learning. And this slide shows timeline of different machine learning techniques. So we see in the 1980s, before the computer was invented, linear regression was used by hand, and neural networks and the concept of neural networks and perceptron was there in the from 1940 to 1960s, as we see. But because neural networks needs lots of data and also it is computationally costly, it was not that popular until recently, until 2010. Like it was neural networks winter between this from 1960s to 2010, but in 2000, since recently it became so popular because of technological advancements, like storage for data and the amount of data we collect, and also advancements in algorithms, like the different kinds of challenges that were there in the early stages of neural networks in the 1960s, using different kinds of research grants, and people came with different kinds of solutions, and that helped neural network and deep learning to be popular, and it enabled it to solve different kinds of problems. So in TF Club, we are going to mainly focus on building machine learning models with neural networks, or with deep learning, basically. And the other thing is, yeah, deep learning is not something new. It has been there, but recently it became popular and a buzzword because of the infrastructure, the data storage, and computing power, and algorithmic improvements in algorithm. All of these things made it so popular. And this slide shows how important machine learning is at Google. So by 2016 Q4, Google had deployed 4,000 TensorFlow machine learning models in production, and they said it has transformed the way they do business. Let me now quickly give this question. So we talked about the different types of machine learning techniques in the previous slide, and let's now imagine you are in the banking and you are creating a machine learning model for detecting if the transactions are fraudulent or not. Is this classification or regression? Yeah, what is that? Yeah, classification, because it is categorical. That's right. So since it is categorical, actually this is just binary. We can have multi-class classification or binary classification. In this case, it is binary classification, like yes or no. And what about from this slide? Is this classification or regression problem? It is regression problem. Why? Yeah. So if you are predicting tip amount from total bill amount and gender, it will be regression because it is continuous data. But if you have the tip amount and the total bill amount, and if you want to infer whether the gender, whether it is male or female, in that case it becomes a classification problem. And so in TF Club, why are we interested in TensorFlow? Is TensorFlow the only deep learning library out there? Actually, there are lots of frameworks for deep learning, but TensorFlow is the most popular one. As you can see here, this is LinkedIn jobs related with that have deep learning tools tags, and TensorFlow is number one. This can be used as a proxy for popularity or adoption in industry. So in TF Club, we are going to talk about TensorFlow and also Keras. Keras is like a UI. It uses other TensorFlow, other deep learning frameworks as a backend, and one of them is TensorFlow. So we are going to use mainly TensorFlow, but also in some cases we will use Keras, who is TensorFlow, as a backend. So what is TensorFlow? TensorFlow is an open source high performance numeric computing and it was developed by Google. It is not only for machine learning or deep learning. It can be used for solving any kind of numerical analysis. For example, in fluid dynamics or thermodynamics, it can be used for solving partial differential equations. And in today's TensorFlow fundamentals, we are going to cover the different APIs, TensorFlow APIs, and also we are going to cover the concept of graph and decision. There are two execution modes, and we will see what they are and what their differences are. And we'll see tensors and different ways that we create variables in TensorFlow. And TensorFlow is like somewhat in any programming language, it is good to know how to debug our programs, especially in TensorFlow. If we don't know the way to troubleshoot our programs, it could be like a bad experience. So knowing mastering how to debug your TensorFlow programs is also important. So we will see some examples on how to debug TensorFlow programs. So in TensorFlow, execution is the computation is represented using what is called DAG, or directed acyclic graphs. And the DAG, it shows the data and also the sequence of operations. The edges are the array of data, whereas the nodes are operations. So in here, for example, in the edges we have input data. These are the examples or the attributes about any observation we have. So this input, we are reshaping it. It is the data. And also we have the weights and the biases that the machine learning model learns from the data. So these are the edges. And we have different operations. We have matmal, for example. It is matrix multiplication of the data and the weights. Then once the output of the matmal, we are adding it with the bias, as you can see here. And once we get this output of this bias add, we pass it through ReLU, or rectified linear reuse. This is like an activation function that changes the output to, it is a non-linear transformation. We are going to see the different kinds of transformations. So what is the advantage of representing the computation using DAG, you may ask? And it has different advantages. One thing is portability. So we can write our DAG in Python and import it to C++ for low latency inference or predictions. And also we can import it to different hardwares. It can be TPU, GPU, or CPU. So it gives us both portability in terms of hardware and also software. But where does the name TensorFlow come from? Why is it called TensorFlow, we may ask? And in mathematics, a simple number, like a single number, it is called rank 0 tensor, or it is a scalar like 4, 5 or something. And if it is an array of number, if it is one dimensional array of numbers, we call it a vector or rank 1 tensor. And we have matrix if it is 2-dimensional. And if it is 3-dimensional, we call it 3D tensor. And if we have 4-dimensional, we call it 4D tensor. So basically, a tensor is n-dimensional array. It can be a simple number, or it can be any high-dimensional array. So the name TensorFlow came from the fact that these tensors, or the data, flows through the DAG, or the directed acyclic graphs. As you see, the tensors are flowing through the DAG, and different operations are being performed on them. So, and hence the name TensorFlow. So as I said, TensorFlow graphs are portable between different devices. So the same TensorFlow code, we can port it to CPUs, GPUs, Android, TPUs, and also we can import it to even edge devices such as phones and IoT devices. this is an example of deploying TensorFlow models that we trained in the cloud to edge device, to phones, for example. We first compress our TensorFlow model output using TensorFlow Lite, then we can deploy it to phones, and in that case we don't need to collect data to the cloud. The model itself on the client side, it can make predictions and it can make adjustments. It can collect data on the device side and adjust the weights, for example, to make appropriate predictions, learning on the way. So, and TensorFlow is actually #1 repository for machine learning category on GitHub, and there could be different reasons for this. One is because it is developed by Google, so Google products are more reliable, and it has very active user community and lots of resources. So this could be some of the reasons why TensorFlow is the #1 repository for machine learning. So what are the different TensorFlow APIs? Let's see the API hierarchy. So at the lowest level, we have the lowest level targets the different hardwares. So it targets CPU, GPU, TPU, Android, and so on. So as I said, we will not care about this for now. And above that, we have core TensorFlow C++. So if you want to create your own numerical analysis library, you can write it to C++ and bind it. And above that, we have core TensorFlow Python. So we'll start with this one. In TF Club, we are going to start with this one. So it is in this layer that many of the Python functions like addition, multiplication, division, and others are available. And above that, we have this layer that helps us to build custom neural networks. TF layers is like when we build different layers, we can add layers. TF losses contains the different losses that we have to minimize in using the gradient descent or using the other optimization techniques. TF metrics contains different kinds of metrics that help us to evaluate our model's performance. But mainly in TF Club, we are going to focus on the highest level of abstractions, which consists of TF estimator and the TF keras. The stable version of TensorFlow at this point is TensorFlow 1.3, and its default highest level of abstraction is TF estimator. But in TensorFlow 2, TF keras will be the default highest level estimator. But anyway, in our case, we are going to see both TF estimator and the TF keras. And this level of abstraction, it has all the requirements for building production-ready machine learning models. If you build your own custom models, then you have to add other things, like, for example, for distributing computing, for saving models, and for making inferences. But TF estimator, it handles all these things. So our main focus, if the model is there in TF estimator, so TF estimator is like, it contains list of out-of-the-shelf models that we can use. If a model is there, we don't need to go down to the second layer, to this layer. We are going to use TF estimator. But if the kind of model we want is not there, then we have to use this layer where we build your own custom neural network. Okay, and TensorFlow has two modes of execution: eager mode and graph mode. The eager mode is it is the same as Python's way of execution. Like, for example, in NumPy, if you have a vector A and vector B, then if you import NumPy, and if you say import NumPy as NP, then np.add a, b, it will just automatically print out the result. So this means it is imperative. In TensorFlow also, there is what is called eager mode. So first we have to enable eager mode by using this. If we import TensorFlow as tf.enable eager mode execution, so it enables eager mode. So I'm creating here tensors a and b. They are constant vectors, and I'm adding them. C is equals to tf.add a comma b. So in this case, it gives me back the results like 8 to 10. As you see, it has also the shape and what the data type. Whereas in the graph mode, it is lazy evaluation. It is lazy execution. So it evaluates it only when we need it. So the first thing it creates is it creates the DAG, the graph. If you see here, we have the tensors A and B. We are adding them and assigning them to C. If we print C, it doesn't give us back the results. It rather gives us the tensor name, where the graph is, and what the shape of the data will be, and the data type. If we want to get the results, we have to use session. So, hey session, please run this and give us back the result, we have to say. So with tf.session assess, so result is ses.run, then pass C. Now if I print result, it gives me the same result as a eager mode. So, and the result in this case is like a NumPy array. So yeah, there are two modes of execution. The eager mode is for development mainly in TensorFlow 1.3. It is for development. It is not recommended for production, and we have to enable it first. In 1.13, as I said, the graph mode is the default one, whereas in TensorFlow 2, eager mode will be the default one. But in production, in any case, we have to use the graph mode. Why is that? Because using the graph mode, it reduces, it minimizes the runtime. So it minimizes the context switches between Python and C++. So it is one way of optimization. So it reduces the runtime. And also the other thing is, once we create the graph, the DAG, we can run different parts of the DAG in different machines, even remotely. So let's see graph and the sessions. So as I said, when we some kind of operation in TensorFlow, it creates the DAG. So here I have C is equals to tf.add a comma b. So it creates this DAG. We have the edges, the data a and b, the operation add as a node, then gives back the result. If we want to run this in the graph mode or in the lazy mode, we have to import session and we have to use session.run. So here, since we don't know a and b, what we have to do is we use feed_dict. So this is, we pass values of a and b here. So as dictionary is like key value pairs in Python, the same as what we do in Python. We pass a dictionary of a and b with their values. So in that case, then it will give us back the value of C. Yeah, and a graph consists of tensors and operations on those tensors. So a typical machine learning, we have here the examples, the weights, and the biases are the edges, and we have different operations on them, the nodes, then we get an output here. So TensorFlow graphs, we execute them by calling run, and this is similar to what I showed in the previous slide. I have tensor x, tensor y, which are constants. Z is sum of x and y. If I print C, it just prints tensor. But if I want to run it, if I want the result, I have to run it under with session. So we use with tf.session assess, then ses.run, the pass Z. So we use this with because after it runs, after it gets the result, it closes the session. That's the only thing. Otherwise, we can also do without it and close the session ourselves if you want. And we can save our graph and visualize it using TensorBoard. So in here I have imported TensorFlow as TF, and X and Y are constant tensors. They are vectors. I have given them names here. So giving them names helps to know which is which when we visualize them using TensorBoard. And we have Z1, which is the sum of X and Y. So we have named it Z1. We have Z2, X times Y. Remember here, note that we have not given it any name. Z3 is Z2 minus Z1. So we can save the graph using TF summary file writer. So first we create a session, and under that TF summary file writer, we give it any name. Then sys.graph as writer. Under that we run any of the tensors. So we can to session we can also pass list of tensors. So we are running list of Z1 and Z3 these tensors and assigning their results to A1 and A3. So in that case it saves the summaries to our local machine. And if we do ls, we can see that it has saved it here, and then we can use TensorBoard to visualize what we have done. So this is a graph. So what this shows is we have tensors X and Y from this side, and there is multiplication in this node. Remember, since this is Z2, since we have not named it, there is no any name here. But in here, Z1 is sum of X and Y, and we have named it Z1. So we see Z1 here, X and Y. In this node is sum, and finally there is this node which is subtract or difference of Z2 and Z1. So TensorBoard, it helps us to visualize the sequence of the operations and the edges, which ones are our inputs, and it also helps us actually to debug our code. Are we doing things the right way? It's very handy tool. Okay, it is here what it is showing is it is possible a list of tensors as I showed in the previous slide. So for under session I am passing Z1 and Z3 and assigning them to A1 and A3. So A1 and A3 are now Python NumPy arrays. And as I showed in the previous slide, to use eager mode, we have to enable eager mode using tf.enable eager execution. So in that case, it becomes the same as Python. By the way, if you have tensors, once we create tensors, like there are some things we don't necessarily need to use tensor functions. Like for example, tf add, we can just replace it by a plus b. When we write a plus b, it knows it is tf add. When we do a times b, if a and b are tensors, then it knows it is tf dot multiply and so on. And next, let's see variables. What are the different variables that we can create in TensorFlow? So we said a tensor is an n-dimensional array of data, right? If it is a simple number, it is a scalar. We have for an example tf constant, and if it doesn't have a dimension. Vector is one-dimensional array. So here we are creating tf constant and passing a vector as you see here of 3 values, 3, 5, 7. And you see the dimension, it is one-dimensional of 3 elements, is what this is telling us. We have a matrix, 2 rows, 3 columns, and you see the shape 2 by 3, and so on. We can also stack them. Here we can create tensors by stacking other tensors. tf constant is one way of creating tensors, but there are other ways of creating tensors. tf constant is not the only one. And the other thing we have to note here is tf constant is immutable. You cannot change it. So most of the time in machine learning we will not use it. I mean, we need to create variables where for the weights and biases, so that we can update their values as a using gradient descent as a algorithm learns. But if it is if you create your tensors using TF constant, then it is immutable and you will not be able to update it. So yeah, to create variables we use tf.get variable. So here I am creating a variable of 2 by 3, it's 2 rows and 3 columns, and I am giving it in my variable. So it is randomly initializing it basically. I can also specify an initializer, the same thing, but the initializer to be zeros. tf.initializers all zeros. So in here we see we have 2 rows, 3 columns, all zeros. And also we can initialize using constants. Constants that consist of 2 and 3. In this case, since this is a variable, I can change its values. So here it was 2, 3. Now I have updated the second number because TensorFlow is 0 indexed. I have updated the second number to 5, as you can see. But for the weights, there are other better initializers. Usually we use truncated normal initializer, and the truncated normal initializer it initializes it from the Gaussian distribution, but it removes outliers. Tensors can also be sliced, is what this is showing. Just if you use R or MATLAB or NumPy, the same thing. The only difference from R is it is 0 indexed. So I have tensor X, 2 rows, 3 columns, and colon means all of the elements are along that dimension. So this one, what it is telling us is all rows, the second column. So the second column is this one, and we want all the rows, so it gives us 5, 6. And if we do the first row, all columns, we have the first row, so the second row, so this is the second. The first row should be 0. So the second row is this one, 4, 6, 8. And it is saying all the columns, so it should give us all of them, 4, 6, 8. And the other point is, so when we are slicing, it is excluding the last, let's say, the last index. So here, this one, for example, it is saying the second column from the beginning, from index 0 to index 1, 2 will not be included. So it will give us only 4 and 6, 0, 1, 8 will not be included in that case. If you want to return up to 8, we have to make it 0 to 3. So if you want to return all the values in that dimension, what you do is up from 0 to, you can use a colon, or another way is to use +1, size +1, length +1, or something like that. Tensors can be reshaped. This is very important when we are building machine learning models later. We are going to use tf.reshape, because once we clean and prepare our data, we may need to reshape our data so that it becomes in the appropriate dimension for our TensorFlow. So we have created here 2 rows, 3 columns, a tensor with 2 rows and 3 columns, and we can reshape it to 3 rows and 2 columns. So what it does is, it knows we are asking it to give us 2 columns. So the first one, it will take 3, 5, 2 columns done, right? The first row is done. Then 7 and 4, the second row. Then 6 and 8, the last row. And also, once we can also chain operations. So here we have reshaped it and also sliced it. So after reshaping, we need the second row, all values is what we are saying. What's the second row? 7, 4. So it returns 7, 4 here. And the other very important thing we have to know in TensorFlow, especially for machine learning, is placeholders. To pass the data in our machine learning, we first create placeholders in the DAG using tf.placeholder. So if I want to create a placeholder, what do? I do tf.placeholder, specify the data type and the dimension if I want. Then I can do different sequence of operations. And for that, when I'm running it under session, I use feeddict and I pass a dictionary. Like, so here I'm running, I want the values for B, but B is A times 4 and A is a placeholder. So I need a dictionary that shows that gives the values of A. So A is this vector, and I use feeddict. So that means now it will multiply it by 4 and return the result. But initially, before using sus, if I simply print, if say print A here, as I said before, it will not give me back the results. It just tells me it is a tensor and it is a placeholder. What dimension it is, what data type it is, it specifies. Finally, let's talk about debugging TensorFlow programs. I'm almost done. So as in any programming language, the first thing we have to do is read the error message and try to understand it, then isolate the method in question, and then send made-up data into the method, and we can use print, like with the made-up data. If the made-up data should be small data, and we print we include print lines, intermediate print lines, so that help us to understand what is happening. And then finally know how to solve the common problem. Like, what was the problem? Once you understand it, how do you solve it? And how do you solve it? It depends on what you initially wanted to do. So one of the common error message in TensorFlow is shape mismatch. So I have here tensor A, tensor C, and I want to add them. When I run it in Jupyter Notebook, it gives me an error message, and it gives me this arrow. It is showing me that the problem occurred here. By the way, when we are running this in Notebook, it gives a very verbose error message that contains lots of different things. But you have to only focus on the lines that start with IPython. All the rest is internal TensorFlow code, and you don't need to worry about it. So here, as you see, when we run this, it is giving us there is a shape mismatch. The first one is a vector, an array is a matrix 2-dimensional. As you can see, the first one we said all rows and the first 2 columns, whereas for C we are saying just for the second column all rows. So that means this will be a vector, whereas this one will be a matrix. And when we try to add them, then there is shape mismatch, is what it is telling us. So one way to solve this problem is, once we create fake data, we add we print the shape. So get shape is one method. So the tensors, they have get shape. So I have a.get shape here, and it prints the shape. Here also I have c.get shape. And as you can see, this one is 4x2, whereas this one is 4. Now, once we know this, we know how to fix it. Do we want to make this scalar like this, or do you want to make this a matrix like this? It depends up to us. So to do this, we have just created fake data here, and we are passing it to this function. The other thing I observed here with TensorFlow, different from the other programming languages from R or Python, is even the input data, we pass it as a function. So we write a function that passes the input data. So that's why we have some function here. We will see this when we create examples. And yeah, we have to know how to solve common problems. Shape is one issue. Scalar vector mismatch is another thing. And data mismatch is another thing. In R, if you are multiplying a float with an integer, it is fine. The integer will be broadcasted to a float. Whereas in NumPy or in TensorFlow, that doesn't work. So understanding such minute things can save your day. So shape we have seen. Once we get the error message, once we understand it, how do we solve it? It depends on how we want to solve it. Do you want C was in the previous slide, C was a vector and A was a matrix. Now we have made both of them matrices, and when we add them, everything is fine. And also shape problems can also happen because of batch size. In the machine learning models, we are going to see such things when we build models using estimator. So related to shape, we have these functions from TensorFlow: tf.reshape, tf.expand dims, tf slice, and tf squeeze. So I think tf reshape could be enough. It can handle all of it. Tf expand dims is it adds one additional dimension, and the tf slice is like for slicing, and tf squeeze is opposite of tf expand dims. So tf squeeze drops dimensions of length 1. tf expand dims adds dimensions of length 1. So they are opposite. But all of them can be done using tf reshape if you want. Yeah, as you can see here, tf expand dims inserts a dimension of 1 into the tensor shape. So here we have x is of shape 3 by 2, and if we expand it, we can add the 1 dimension. We have added 1 dimension, so it becomes 3, 1, 2. And if we use tf squeeze, it drops this dimension and it comes back to this. Yeah, tf squeeze removes dimensions of size 1 from the shape of a tensor. Data type, I have said about that. So you cannot add or multiply float and int, for example. So in that case, what you have to do is you have to cast the int to float using tf cast. We have this method, tf cast. So these are among the common kinds of error messages, causes of errors that we can face in TensorFlow. And we have this debugging techniques, tf print. Also we have tf debug and TensorBoard. In TensorBoard, when you visualize the DAG, and if you can notice if there are shape mismatches, or if things are misplaced, like if the edges are not going to the right nodes and stuff. So TensorBoard is very handy for debugging our code. And actually TensorBoard is also useful for visualizing if our model is performing what is expected to do. Like rather than running your code for 2 days and finally figuring out that your model was wrong, in TensorBoard you can save, it saves intermediate results, evaluation results, and this you can see if the model is improving its performance. If it is not improving at all, that means there is some problem with it, and you kill it and you start over after figuring out what is happening. With tf debug, it is kind of to get where exactly is the problem happening. You have to drill in and scroll down through lots of code. So tf debug is not an easy thing. I think TensorBoard and the tf print and understanding the common ones like the shape mismatch, data type mismatch, are very helpful. So I think this is enough for today. Next week we are going to continue building machine learning models with TF estimator. So next week it will be fun, I hope. But for this week I'm going to post programming exercises with their solutions on the channel. So please, over the weekend, spend a couple of hours and try them out, please, and have a good weekend.